We're now going to take a look at the derivatives of logarithmic functions. And so essentially, what the rule for derivatives of logarithmic functions tells us that if we're taking the derivative with respect to x of log base b of x, and of course b has to be a positive real number, then that's going to be equal to 1 over x times the natural log of b. So it's a little bit more complicated than the formula for the derivatives of exponential functions, but it still is very similar because again, we're kind of scaling up by we have the natural log of b over here, the natural log of our base. However, it is a little bit different, we no longer have our original function over here. We're kind of converting from log base b of x to 1 over x times the natural log of b. And so essentially what's very useful is to actually identify b before we even consider the derivative. So let's go ahead and do that for these couple of problems over here. And so we're taking the derivative with respect to x of log base 7 of x. That's our first example. And essentially in this case, our b is going to be equal to 7, right? Because our base is 7. And so we can just go ahead and input that into our formula. So we're going to have 1 over x times the natural log of 7. And then that would be our final answer. And so again, once you actually learn the formula and get comfortable with it, it's very easy to actually take the derivatives of these different functions. And again, we don't have to simplify this natural log of 7. We can just keep it as it is because it's kind of just a scaling constant. It's a real number. It's a scaling constant. The next one over here, we have the derivative with respect to x of the common log of x. And we know that for the common log, we know that the base is equal to 10, right? Because we have kind of a hidden 10 over here that's usually not written for the common log. And so we kind of have this little hidden base over here, which is equal to 10. And then we can go ahead and do the exact same thing. We can just input this into our formula. Here we'll now have b equals 10. And then we'll get x times the natural log of 10. So 1 over x natural log of 10, and that would be our final answer. And now for the final one, we have the derivative with respect to x of the natural log of x. And we know that the natural log of x, another way to rewrite this is log base e of x. And so in this case, our base e, or our base b is going to be equal to e. And then what we can do is we can just go ahead and input that into our formula over here. So 1 over x times the natural log of b, but in this case, our b is equal to e. So we get 1 over x times the natural log of e. But we know that the natural log of e is going to be equal to 1, right? Because we know that e to the first power is equal to e, because the natural log of e is just telling us what power do you have to raise e to get to e, and that's going to be equal to 1. So we know that we can go ahead and simplify this out. This is going to be equal to 1. And so then we get that the derivative with respect to x of the natural log of x is going to be equal to just 1 over x. And so this is a very nice little property over here when we're taking logarithmic derivatives, because using the natural log and taking its derivative is something that's going to appear very often later on, especially in differential equations, because we can use the natural log to kind of simplify expressions significantly. And so this right over here is essentially all we need to know about the derivatives of logarithmic functions. And again, it's not too difficult. Again, maybe a little bit more complicated than exponential functions, but very similar in concept. All of these different properties and rules, they have their own proofs, but we're not really going to delve into the proofs because it's kind of outside the scope of calculus 1 and AP calculus. So we're kind of just going to accept it for the time being, but maybe later on we will delve into the proofs behind all these things if we start looking into real analysis.